Hey everyone, so as you know, there's a new wave rolling through the AI world right now. So there's a new skill in the market everyone has been talking about called context engineering. So for a while it was all about prompt engineering, as you all know, crafting the perfect words was a skill. But now we are actually entering a broader, more powerful paradigm known as context engineering. So this is about managing the model's entire working memory and not just the prompt. So let's break it down. We are actually going to unpack what context engineering actually means, why it is different from prompt engineering, and the mess it is solving right now, and also the real tools you can start using today. Let's get into it. Okay, so let's look into what context engineering actually is. So it is basically managing the model's entire working memory or the context window appropriately as per your requirement. I really like the analogy provided by Andrej Karpathy. So he says us to think of an LLM as the CPU, which is doing the heavy lifting for them. But what about the context window? That's actually your RAM. It is actually the working memory which is powerful but also limited. So, putting everything you can into the window might seem smart sometimes, but it's the number one reason why so many agents failed in weird and hard to debug ways. So, to understand context engineering, we first need to expand our definition of context. It is actually not just your prompt. So, it is everything the model sees before generating a response. That includes your system prompts, that actually sets the tone, role, and the behavior. There's the user input, which is the actual question or request, your chat history or the short term memory, which is currently ongoing. Then your long term memory is all of the sessions which you've had before, the facts, preferences, and the state. Then we have RAG or retrieved knowledge that comes out from search APIs or external files. And there's your different tools such as calendar, Gmail, and different tools which comes, and that is basically giving the model what it can do right now. Other than that, there's also the responses which we get from tool calling, part of the context. So all of this is your context, and if not engineered correctly, you're actually flying blind. Let's now go and look into the difference between the context engineering and prompt engineering. So prompt engineering was essential when models were chunky. You had to babysit the output with perfectly tuned phrasing. But today's models, they actually get your intent even from messy inputs. So the real limitation now, it's the context window size, which is limited to different models. So for Gemini, it's 1 million token. For Anthropic, Claude, it's 200K. So every message is now burning tokens, and models degrade as they approach the limit. So more tokens is not equal to better results. Often it means worse. So context engineering is basically about working with that memory architecture and not against it. Let's now look into who does this actually impact. So if you are a casual user, if you're just chatting with ChatGPT, prompts are fine for you. But if you're actually building real agents or a developer right now who's trying to build real applications using RAG tools, using long-term memory and feedback loops, this is definitely for you. So efficient context management is make or break in those use cases. It's not about quality, it's actually about control, cost, and capability. We'll now deep dive into the different perils of crowded context. So, there's a lot of different problems which we get with poor context management. Looking into all of those, dumping too much into context causes four major issues. So, context poisoning, a wrong fact early on, it actually snowballs into every single answer. That's basically hallucinating. Context distraction, when there's too much noise, the model actually loses the signal. Then there's context confusion, poorly structured info leads to misinterpretation. Then there's context clash, which means contradictory data leads to hesitations and error. These aren't actually real bugs, these are default failure modes. Okay, so let's look at how to solve some of these problems. The good news is we have a powerful toolkit to fight back and manage the memory effectively. Let's walk through it. RAG, it can actually retrieve only the most relevant information right when it's needed. Tool loadout can actually help and only give the agent the tools it needs for the current task. Context quarantine would actually isolate different tasks in their own context. Context pruning would actively trim old, irrelevant parts of the conversation. Context summarization can help condense long conversations into tight summaries. And then context offloading can help use an external database as a long term memory. So, this is memory management for LLMs done right. Uh, so, designing context isn't just about adding memory or doing retrieval, it is basically system architecture. It's the difference between an agent that responds and one that remembers, reasons, and adapts. So, how do you build that kind of context loop? So we've got something from LangChain here. They've actually identified four different pillars of context engineering, which really explain this concept. First one is writing context. So use memory basically like a scratchpad and a journal. So you basically need two kind of memory here. Short term, it should be used like a scratchpad for stuff that agent is working through right now, like search results, partial reasoning, tool outputs. They should fade away after a task ends. And then after that, we've got the long term memory, which is stuff that actually should stick around, like the user's name, preferences, or what actually happened last week. So you write it once and it shows up again when it's needed. So the key here is that memory should exist to support action and don't just dump logs. It is basically asking us to create meaning. Moving on to the next one, selecting context. Only show what matters. So dumping the whole chat history into LLM every time, that's lazy. So good agents actually pick the right context for the moment. For tool calls, they only bring the relevant data. For planning steps, they look at past decisions. For personalization, they pull up user preferences and not the whole user log. So each step can actually fetch exactly what it needs and nothing more. And retrieval that understands why it is retrieving. So implementing a RAG feature which is able to do all of this can go a long way. Then we talk about compressing context. Keep the signal and drop the noise. So when you give the LLM too much context, it leads to confusion. So LLMs don't think better with more words; they think better with better words. Let's say you got like 50 messages in a thread. Collapse all that into three bullet points. Tool gave a giant JSON dump. Strip it down to what it actually means and what matters. Long task with 5 step, summarize the key outcomes. So the point is, don't let your agent get buried in its own memory. You're not just pruning for token limits, you're shaping cognition. Shrink it, clean it, and then use it. Next is isolate context. So keep threads separate. Context bleeding across step will cause chaos. When every part of your agent shares the same memory, things get messy fast. So keep things clean, have sandbox execution. So tool calls don't actually leak into reasoning until their outputs are intentional. When you have multi-agent orchestration and you need a planner, a doer, and a QA checker, keep their context separate, then merge when needed. So context lives in its lane until it is needed. So clean separation isn't overhead. It's actually how you avoid hallucination by contamination. That's context engineering. So write the right things, pick the useful bits, trim the fat, and keep it clean. And when you do that, and suddenly your agents stop feeling like a chatbot and it actually starts acting like it knows what it's doing. This is basically your blueprint for building reliable, powerful AI solutions. A few more additional recommendations which I would like to give. So, first up is priming the agent. Instead of actually throwing a model into a task cold, give it a warm up. Ask it to read background files, then summarize it. This forces it to internalize the data before working on it. So, you're writing context deliberately, setting it up for success. The second one is agents can't actually basically read your mind, so they need specs. You need to give them specs, even imperfect one, whether if it is a bulleted list or a big messy voice note. That is okay. So you are basically selecting context and deciding what matters and when. This is how you steer the model with precision. The third one is activating something called the ultra think mode during the planning phase. So ask the model to plan before it asks. Start with think, escalate to think harder, and then maybe escalate to ultra think. This would actually burn more tokens, but would give you richer, deeper outputs. So you're not just compressing context, you're distilling thoughts into a plan before even it takes action. And isolating context by carving out planning as its own phase. The last one is feedback loops. The best agents don't just execute, they test, observe, and iterate. So give the agents the ability to compile, run, and test, and then learn from their failures. This is a real time context selection based on what the agent just experienced. It also is task isolation, keeping the debugging info separate from the core logic. So to recap, write what matters, select what is useful, and compress the noise, and then isolate the flow. This is how you move beyond chatbot tricks and start designing cognition. So there you have it. As LLMs evolve, context engineering is the real lever of power. It is no longer about fancy prompt. It's more about managing memory, precision, and relevance. Master this, and you're not just prompting anymore. You are programming cognition. If this actually helped, share it with someone who's building agents and drop a comment if there's any specific topic you want me to dive in next. Catch you in the next one. Thank you.